morning, everybody, and welcome to our second episode of Cosmic Coffee, here coming to you from Lowell Observatory. I'm Jeff Hall, an astronomer and the director of the observatory, and I'm here today with our outreach manager, Sarah Bircher. We're actually pre-recording this. You're seeing this on Thursday morning. Right now it's a little after 4 p.m. Tuesday afternoon. The sun is setting in the west, so it would be a little lame for us as an institution of astronomy to pass this off as morning. But we're doing this because in a little bit less than an hour we will enter a stay-at-home order issued yesterday by Arizona Governor Doug Ducey that will further constrict our ability to bring you our online streaming content during these days of lockdown. But it was definitely the right thing to do. We are, as I've said before, an institution of science, and we need to do what the science and the data are telling us. And the data of how the virus is transmitted are pretty darn clear, and distancing and isolation will make a difference and will help get this thing back under control. So we're going to observe that strictly. You can see we're observing the separation here. And going forward, we'll be coming to you mostly from our living rooms. We certainly encourage everybody else to do the same and help us all get through this with as little impact as we can. One of the themes for Cosmic Coffee is to give a little support to Flagstaff businesses and in particular our coffee shops. For this episode, we're featuring Macy's. If you're a Flagstaff local, you hardly even need to be told where Macy's is, right down there a few blocks south of the tracks on South Beaver. Certainly encourage you to go pick up some of their good fare. Been there many times, and it's always a pleasant place to be. Please get out and support your local shops as they struggle through these economic times. So now we'll get on to the topic for today, which is a behind-the-scenes tour of our new Giovanni Open Deck Observatory. Regrettably, not a visitor in sight. We certainly would like to see them here. But what we thought we'd do is give you a tour of the spectacular telescope suite that we've put together for this facility, and then a little bit of a tour of the whole facility so that when we can reopen, you've got a little idea of what's up here if you haven't been here, and hopefully can come see us at some point. Now, Flagstaff hosts an annual awards ceremony called the Viola Awards. I've been doing it for over 10 years now, and this year we were thrilled that the Giovanni Open Deck Observatory won the award for Best Achievement in Placemaking, creation of a cool new resource for our community. As part of that award, they had our senior educator, Jim Cole, describe what we were trying to do. And here we're going to show you that clip that he made for the awards.
Lowell was a real believer in educating the public on science that was done at his observatory. So we've carried that forward. It's actually in the mission statement. In 2017, we bumped up against 100,000 visitors a year. And so out of the need to grow, we came up with an entire master plan. And the first part of it was the Giovanni Open Deck Observatory. It's basically an observing deck with 6 state-of-the-art advanced telescopes for the public to look through. It is unique, and we think in the world there's nothing like this anywhere. The dark skies here in Flagstaff are one of the great natural resources of this area. And so all of this, I think, is very important, not only for people to look through a telescope, but to actually think about things and start to realize that they're a piece of the universe. We're not isolated here.
So now we're going to start with a tour of the telescopes here at the GODO. And to tell you all about them, our outreach manager, Sarah Bircher, is here with us today. And we're going to go through the telescopes one by one. So I think you told me before you want to start with this little one, but it's small but mighty.
So this one is our smallest telescope up at the Giovanni Open Deck Observatory, but it's my personal favorite. I'll go into why in a minute. But this is a 5.5-inch refracting telescope from the Telescope Engineering Company, and this guy is fantastic in a lot of ways. It is a triplet refractor, which means it's got 3 lenses right in a row, and the middle one is a grown crystal lens made out of fluorite, and it's grown in a lab so that it can be incredibly perfect in its structure. And what that means is that this telescope is fantastic at focusing light right down to a pinpoint. So if you look at stars through this thing, they are just tiny, tiny little pinpricks of light. But that optical quality also allows us to see incredible detail on things like the moon and planets and such. So even though it's a smallish telescope, it can give us a whole lot of views like you've never seen before. But where this one's power really is, I think, is in its field of view, of how much of the sky it can see. And so this telescope can see at its widest a 3-degree field of view. Now 3 degrees is about 6 times the full moon in the night sky, which is really, really big. And you may be thinking, wait, aren't telescopes for looking at something really close, right? Isn't that why we get telescopes? And yeah, telescopes are great for that, but there are so many things in the night sky that are really big. Like the Andromeda Galaxy, for one, is about 3 degrees wide. And so you need a smallish telescope with a fancy eyepiece to be able to get that whole thing. And so if you know anything about eyepieces, you can see that this one is gigantic. It's about the size of my head. And this is what allows us to see that incredibly wide field of view for things like the Andromeda Galaxy, open star clusters like the Pleiades, which we have a video about now. Yeah. So I also want to show you how we manage these telescopes, how we point them. And we point them with an iPad running Sky Safari, and it's pretty fantastic. I can just point and click, and my telescope will go where I want it to. And this is so easy that on kind of slow nights around here, I'll even have kids, you know, come up and pick an object and slew the telescope themselves, and then I can just kind of adjust it as I want. Now, there's another way we can adjust these telescopes up here at the GODO, though, and that is this pier that the telescope sits on is adjustable, which means that the eyepiece where you look into the telescope can change its position, right? And so it can go up and down. And the important part about this, one, it makes things really comfortable no matter how tall you are, but 3 of our telescopes are mounted on these types of adjustable piers, and they make those 3 telescopes ADA accessible under most conditions and in most positions. So I just think that's a fantastic message we want to send out, that astronomy is for everybody, and we're doing our best to do that here. And
absolutely, thanks, Sarah. And throughout all of our plans to design our new outreach facilities here, we are trying to maintain the highest level of accessibility for any visitors who want to come up here and enjoy the wonders of the cosmos. So now we're going to move from this small one over here to this telescope. Now, the technical term for this variety of telescope is badass.
All right, so we're going to talk about our second badass telescope here. And you'll notice it's probably the most striking one we've got here. We spent a lot of time trying to pick the color for this telescope, and you can see that it's actually a candy apple red, like you'd find on a Mustang or a Ferrari, and with this gorgeous silver trim. So I think we picked the right one there. So I'm actually really quick going to move this one for you. It's incredibly long, right? So I'm going to have it move, and just let you guys see how it does that. So yeah, it moves just as smooth as the little guy. It does weigh 130 pounds, which I think is a little bit less than what I would have thought with this one. But this telescope is similar to our previous one, the Tech, and that's a refractor as well. And it's got an 8-inch lens instead. And what that means, having a bigger lens, is that this telescope can collect more light. Telescopes are basically just light buckets. And the bigger your bucket, the more light you're going to get. So this one can gather a little bit more light. And it's really good for looking at planets. We like to look at planets with this guy, and hopefully this summer we'll have Jupiter and Saturn through it, which should be fantastic. And in the fall we'll have Mars. But yeah.
Yep. Saturn through this thing is absolutely spectacular. Seeing the shadow of the rings lying on the planet, you can just clearly see it. It makes it look totally three-dimensional.
Yeah.
Really fine addition to the facility. All of these telescopes were gifts to the observatory from many of our generous donors. This one from our advisory board with the Tech, from our advisory board member Don Paul, and this from our good friend of Lowell, Don Trantow. So now we're going to move over to our 16-inch Meade and talk about that one. Okay, so this is our 16-inch Meade, a gift to the observatory of a wonderful friend of Lowell, Barbara Robinson, and her late husband, Kent. Now this is a 16-inch aperture, so twice as much as the Moonraker, but considerably more compact, so a totally different optical design going here.
Yeah, so we do have a large dew shield on this. This entire telescope, remember what Jeff was just saying, is twice the reflecting surface of the big red one we were talking about. But the telescope is only like 3 or 4 feet long, right? It's a tiny little guy. And the reason for that is this is a very, very different type of telescope. It's called a Schmidt-Cassegrain. And what it does is it uses a combination of mirrors and lenses to basically fold the light path of the telescope, bounce that light around a couple times. And so you can have a much bigger telescope in a much smaller space. And this combination of mirrors and lenses, and just the idea of using mirrors in general, is what is really common in research telescopes nowadays. You won't really ever see a research telescope that's just a refractor like the Moonraker, like the Tech, or like our 24-inch Clark telescope, because they just get too big. Where this guy, because of its optics, can get a much larger reflecting surface, a much larger light bucket, without having the problem of size. So let me open this up and move it a little bit so you can see him go. Hang on, sometimes it takes the iPad a second to connect. But let's go watch it go. Isn't that so smooth? Right, these guys are crazy.
Silky smooth, and also on one of the adjustable piers.
Yeah, and that's neat. So this telescope, because, actually I'll wait for it to finish doing that. Because it folds light so many times, this telescope has a very, very small field of view. So remember I was talking about with the Tech, it has a large field of view, you can see a lot of the sky. That guy can see about 3 degrees. This guy sees about half a degree, right? Which is not a whole lot of sky. And so my favorite thing to view with this is actually binary stars, which Lowell Observatory is actually known for having studied way back in the day. But binary stars are stars that are star systems that are 2 or more stars hanging out together, and this one allows you to see the separation in those stars very clearly. So that's my favorite thing to look at with this one.
Yeah, very nice telescope. And now we will move over to the real monster, at least as far as aperture is concerned, and that is our 32-inch star structure right over here. Okay, so the 32-inch star structure telescope here is a gift of the Nackert family, the Pepsi distributors here in Flagstaff, and this is a 32-inch f3, so
Yeah.
a pretty fast optical system.
Yeah, so that number f3 refers just to the way light is focused throughout the telescope. I don't really want to go into the fancy specifics at the moment, but it means that this telescope is really stubby for how big it is. Right, a 32-inch mirror, which I don't know if you can see it in there, but it's pretty big. Yeah, so 32-inch mirror, I believe, is tied with the largest telescope that's like generally available for the public to view through in the United States. So that's pretty big. It's actually the biggest telescope we have up on this campus at Lowell Observatory. But normally, when you have a bigger mirror, bigger lens, you need a longer tube, like we were talking about. But this guy, its mirror was made to focus the light so that it came to a point very sharply, which meant it could be a stubbier telescope, which means that the eyepiece is not very far from the mirror, which is good because that means you have to go up fewer steps to see it, to see through the eyepiece. So even when this is straight up, you usually only have to go up 2 or 3 steps to be able to see through it. But back to that mirror, that 32-inch mirror is enormous, right? Which means it can gather so much light. Right? And so what that means is this guy can see fainter things than any of these other telescopes in better detail. So I love putting this guy on distant galaxies that are 10, 20, 50 million light years away. Show up really nicely in here.
And because of this huge aperture and the amount of light it collects, we can also get color.
Yeah, we can get
on some
color.
of the brighter nebulae, which is really cool. Now, what about, there's also the fan going down.
Oh yeah, so you can probably hear it. There's a fan going through here because telescopes don't really like to be hot. They actually really like to be the temperature that the outside is. Because if you have a telescope mirror and the outside being very different temperatures, you get a lot of atmospheric distortions. So we turn on fans to try to cool this guy off. But this mirror is even fancier than we were talking about earlier because this mirror is quartz. And that allows it to cool off a lot faster than a big 32-inch thick piece of glass. Yeah, so you can see the mirrors supported here, and you might be able to see a couple of the fans that go, that blow it off there, but yeah, pretty fantastic. Moves pretty smooth too. I'll bring it up for you guys so you can kind of see it go. Moves pretty fast for a behemoth of a telescope, I would think. So,
Terrific instrument.
yeah. We had the Orion Nebula through this telescope for most of the winter, and just the amount of texture you can see in that object. That object is fantastic through any telescope you got, but through this one, it's pretty special. All right.
Very good. All right, now let's go over and take a look at our spectacular PlaneWaves. There's a pair of them, a 14-inch and a 17-inch PlaneWave telescope, extremely high quality. Gifts of the Don Neerling Memorial Foundation and Lowell board member Eric Johnson and his wife Peggy. And we use these in a different mode than the other telescopes, and they really move around.
Oh yeah. So I'll show you the motion of it first. These are just crazy how silent they move. We call them the ninja telescopes because they'll just sneak right up on you. But I wanted to actually bring it in this position because on the back of this telescope we have what's called an instrument selector, which allows us to mount like 3 or 4 different instruments on this. And we have actually a high-tech camera from the same donor who gave us the telescope. Eric Johnson gave us this camera that we're working on getting set up. And also attached to it is a spectrograph. And this is really cool because a lot of astronomy science nowadays is done via spectroscopy.
So one thing that's tremendously appropriate about this spectrograph, we've mentioned how these telescopes have been gifts to the observatory from various supporters and members of our board. This spectrograph, right here, there's a little gold plate that says the Ed Slifer spectrograph, and that was a gift to the observatory from Ed Slifer, who is a descendant of the Slifer family. And if you know your Lowell Observatory history, you know that Vesto Melvin Slifer, who was the director here for 40 years, in 1912 made the first observations of cosmological redshifts using the Clark telescope up on the other side of campus. The birth of what eventually became the Big Bang Theory and our understanding of the expansion of the universe. So collecting spectra for people using the Slifer spectrograph is tremendously appropriate. And we talked about spectroscopy a little bit at the last Cosmic Coffee. The spectrum of a star or an object is essentially its fingerprint, marked throughout with different absorption and emission lines created by different elements or molecules in different physical states. And we can tell an enormous amount about what's going on in an object. So if you were tuned in last week, you learned how Phil Massey and his collaborators used spectroscopy to figure out what was going on with this curious dimming of Betelgeuse. And the neat thing about our pair of PlaneWave telescopes, as Sarah was saying, we have a spectrograph attached to this one, an imager attached to the other one, so we can project onto these screens images and spectra of the objects that we're looking at, and besides being able to talk about all of that, 40 or 50 people at once can see what's going on instead of just one person looking into the eyepiece. If we come around to this side, this is where the crowd would normally stand, and right here on the screen, Sarah's displaying a characteristic spectrum that we might get. This one is actually of the sun, and you look carefully and you can see these dark lines in the spectrum that are characteristic of different elements. So this is a characteristic screen. It looks a little dim right now because it's daytime, and this is set to have its brightness dimmed for use during the night. But this is just one example of what you can see from a spectrum. You can see all these dark lines digging down into the spectrum, and that's the signature of different elements. Several of these, this one right here, this one, these are all lines created by hydrogen, which is what the sun is mostly made of. Right there is a line created by sodium, and then right over here, way down here, are little lines created by calcium, and those are actually the lines that I have been principally studying for over 25 years here at Lowell in our long-running solar and stellar activity cycles program. So now we'll let Sarah tell you a little bit about this one and our cool imager.
Yeah, so we have the 17-inch PlaneWave, right, with its cool spectrograph, and we have the 14-inch PlaneWave, which has a 10.8 megapixel Malan Cam DS10C Tech, if you want to look up the make and model. And it is a fantastic camera that allows us to take live images of deep sky objects. And I'll have you display some of those on the screen at the moment, but we can do in probably most of the time less than 30 seconds. We can show real color, real-time images of the night sky, because normally when we look through telescopes, just the human eye is not very good at processing color in low light. So most of the stuff through telescopes come out as black and white, or maybe a little bit of color, pink or green here or there. But when we get a long exposure camera on it, a nice telescope, we can pull out those incredibly vibrant pinks and reds that are indicative of hydrogen, or greens that are indicative of oxygen, that show up in these objects that we couldn't normally see. And this also, because we can gather so many people around here, gives our educators to talk, to answer questions directly, when normally the lines at other telescopes would prevent that. We can allow conversations to evolve about the big questions.
Okay, let's talk a little bit about how this whole facility works. As I think everybody can see, those are permanent piers, and we're out here exposed to the elements. So tell everybody about what the design of this whole thing is.
Yeah, so that's actually one of the most common questions I get at night, is people wandering up here being like, do you take these telescopes out every night, or are these guys just out all the time? The answer is no. This entire building, this entire gray structure you see here, actually is on wheels. It's got 4 motors and 4 sets of wheels that pull it along this, essentially a train track, right? And it moves pretty quickly and pretty quietly for such a big thing, and that's what protects our telescopes. In about 2 minutes, it'll slide all the way across them, and then a garage door will lower, safely encasing all of our telescopes.
Yeah, you can see the garage door right up there, sort of like a hangar door, and that will eventually come down and close, and then the whole thing is zipped up. And this increases our efficiency tremendously. You know, the overhead on the educators having to lug telescopes in and out used to be terrible. Now we can just spend all that time and effort actually showing people stuff through the eyepieces.
Exactly.
So we have all these permanently mounted telescopes in this fancy rolling building. What was the motivation for all of that?
Well, we're always trying to improve guest experience, because before, the way we would do things is we would have to haul telescopes all over campus, and those telescopes were portable and therefore not as high tech. Basically, they were just mirrors on wheels. And that meant that our educators were the tracking system for these telescopes. And so every 2 or 3 guests, they have to step in, interrupt, and deal with the fact that the Earth is moving and adjust the telescope slightly. But these permanently mounted telescopes are all nicely aligned, right? They point at wherever you want, and then they'll just track, which means that we can engage with guests a lot more than we were kind of engaging with the telescope. So we can spend that time making sure our visitors understand exactly what they're looking at and get the most out of their experience here.
Yeah, that was something that surprised even me after we were open, coming up here and seeing how fast the lines were moving and how much more efficient it was. You know, we designed the thing, and I wasn't even expecting it to work that well. Okay, so let's talk about some of the other features of the GODO. It's not just the telescopes, although those are certainly the centerpiece. There are several other things going on around here. You may have tuned in a few weeks ago to our Equinox program. So tell us a little bit about our Stonehenge here.
Yeah, so as you'll see behind, you've got 3 plinths lined up on this. This is the west side of the GODO. And what those 3 plinths are is showing exactly where the sun sets on 3 important times, 3 important days of the year. Where Jeff is standing right here is where the sun will set on the winter solstice. And this is a cool exhibit. We have our marker here, and if you stand right at the marker, you can see through the hole where the sun will set. And you can repeat that exercise and see how the tilt of the Earth changes what happens to our sun over the course, or our view of the sun over the course of a year, which is fantastic. Just, I've seen kids here just being amazed, looking through all the holes and just kind of putting that piece of science together, and I love watching that happen.
Cool. Now, in between the plinths, along the railing, there's all of these plaques.
Yeah, and this is an ingenious way to incorporate more people who wanted to help us out in funding the GODO. So when we were starting up the fundraising for this, our donors were able to purchase these plaques where they could get their name and, of course, the name of whoever put the quote on them. So each of these plaques has a quote on it, or even an equation of something important in science or astronomy. And so this was a way for you to give a personal gift to the observatory and show what's important to you in these quotes as they will line the entirety of the GODO. There's like 100 of these things. So a lot of member and donor involvement there, which was fantastic.
Member and donor and staff, you can see right here, there's a couple of great examples from the Van Bell family, one of the famous equations in astronomy. And then right over here, one that says, "We are Stardust," sponsored by David and Lisa Actor. Lisa is our Deputy Director for Development. This is a really good quote. As you can see, we have everything from quotes by famous astronomers to Joni Mitchell. And this is an appropriate one because this is a theme we're trying to build into some of our future programming. We are literally children of the cosmos. The atoms in our bodies were forged long ago in the cores of long dead stars like Betelgeuse, like we were talking about last week. So what about the yards too?
Yeah. So on each side of the GODO, we have these mirrored grassy areas. And I can't tell you how many nights I've come upon people just using this area to stargaze. Because Flagstaff, as we know, is a dark sky city, right? We have gorgeous, gorgeous skies on any clear night. And so people will take advantage of this. Kids will play in the grass. And we also have these benches, another donor opportunity that are a little bit reclined, so you can also take a look at the night sky with those.
And then in the background, as part of the whole GODO project, we're actually fairly far from the Steele Visitor Center right here, and it's kind of dark and large crowds are up here. So thanks to a very generous donation, we were able to build what we call the wash house over there, a nice set of bathrooms for men and women, and we just couldn't resist working in some exhibits inside that building that have a little bit of bathroom humor in them. And you know, it's a little much to trek over there right now, but we encourage once we're open again, come check out the exhibits in there. We think they'll give you a good chuckle. We've mentioned that the telescopes were made possible by many generous donors. In fact, this entire facility, which in the end was $4.4 million, was made possible through contributions from many wonderful, generous people who made this fabulous experience possible for all of our guests. And here is our beautiful donor wall where we recognize all of them.
Yeah, and this actually lights up at night, dimly, to not mess with our night vision, but this is probably, at least of the outdoor exhibits, one of the most spectacular things on this plaza, because you just wander back here at night and you see all of these gorgeous, gorgeous pictures of deep sky objects just singing the praises of the people who helped put this facility together.
Yep, and here you will see the names of many people that I mentioned before in terms of funding the telescopes, such as Eric and Peggy Johnson, many of the exhibits, such as the APS Foundation right here, and then the namesake of the facility, the Giovanni Open Deck Observatory, made possible through a lead gift by our wonderful benefactors, John and Ginger Giovanni. We've used many different images for the donor wall, but in fact a lot of them were taken right here in northern Arizona with the Lowell Discovery Telescope. This being one example, this is another one. So we're trying to use some homegrown imagery to honor our donors as well. All right, well, we're about done with our tour of the GODO. It's getting late. We're only a few minutes from breaking curfew, and I think we're all getting a little punchy here. So we're going to finish up talking about this really cool item that we've added as sort of an extra thing for our visitors to do while they're waiting for views through the telescope.
Yeah, this is a fantastic tool known as a Planisphere, and you may have seen them in shops or on the internet. It's just a little paper thing you can spin, and by lining up the date and the time, you can see what in the night sky will be up that night. So Jeff, do you want to give this a spin for me?
Yeah, actually, before we shot, I mean, so here you look around the perimeter, you see January, February, March. We're filming this on March 31st, so if we dial this right around so that March 31st lines up with 5 p.m. on the dial, which is about what we're getting to, then this shows the sky as it currently is. And so what we can see is that right up there in the south is Orion and Betelgeuse, which we were talking about last week. It's right up there. As night goes along, see, Orion will be gradually heading over to set in the west. So at any time of night, any day of year, our visitors can dial this up and get an immediate visual depiction of what the sky looks like right then.
Yeah, and you mentioned this is usable at night because it does light up. in nice.
Oh, it's beautiful.
Yeah, in nice low levels for because we're right next to the telescopes. But this means that you can be standing here on any given day at any given time and spin this to what time it is and see, give yourself your own sky tour up here.
Okay, well, thanks so much for joining us for this episode of Cosmic Coffee. We're getting up to 5 o'clock, so we're going to have to run home and go hide in our living rooms and be responsible citizens, as we want to be during this time. We do have quite a few events coming up. Tomorrow, we will have a virtual event concerning the passage of Venus through the Pleiades, which should be a spectacular sight in the night sky. Next week, we will have a program centering on the full moon, which is one of the so-called supermoons that we hear about so often. And Cosmic Coffee next week will kind of riff on that a little bit with a lunar theme and a bit about Flagstaff's role in exploring the moon. So until then, on behalf of all of us, we really wish you all the best in this rather uncertain time. It's a little bit sad to see the plaza here completely empty, but it's definitely the right thing to do. And to the best of our ability, we will continue to bring you some interesting and neat content from here on Mars Hill, Flagstaff, Arizona. See you soon. You are on Slack.
Yeah, I don't know if
go follow. We were having a conversation today. This new unit of distancing is 1 llama.
Okay.
And did you know that the distance to the sun is 81.8 gigallamas?
I did not.
Okay.
But again, is it referencing any Joe llamas specifically, or llama the animal?
There was a graphic showing 2 people spaced by 1 llama,
Okay,
which
so
was safe distancing in the era of COVID-19.
Yeah, I may have to Photoshop that to be Joe llama.
Yes,
So-
that's right.